Yeah, if you can't hear me at any stage, please just get to repeat it. But the student says I'm a psychiatrist. So I've been in private practice for a long time, but I recently set up a memory clinic in Thuringia, and my particular interest in dementia assessment, cognitive assessment, psychiatry of old age, and so on. And clinics called Your Brain and Mind. But I've been working in the field for about 15 years or so, and I'm particularly interested in working with people with dementia as well as the people that look after them, but also very interested in the sort of more preventative side of things, so what we can actually do to try and keep our brains healthy. And of course, it's sort of really relevant to all of us, in fact, whatever age we are. So I think that's one of the points that I'd quite like to sort of get across here, is that you really should be sort of looking after your brain years before we sort of traditionally see things like dementia develop, because a lot of these conditions can actually start to manifest without symptoms in the brain decades before we actually traditionally see it. So I was asked for a title, so I came up with a modern brain, which I realised in retrospect is probably a bit grandiose actually, and there's a lot to talk about in general, and what I sort of going to start off just talking about the basics of brain anatomy, a little bit about cognition and so on, then talk a little bit about dementia, common types of dementia, including Alzheimer's, and then what we think might be contributing factors to Alzheimer's, and we'll go through that to a degree. And then I've just sort of picked out some element of the preventative side of things that I've just done a slightly deeper dive on, and we'll just talk through those as well. So just see how we go. Okay, so issues to consider, I guess when we're talking about the modern brain is, what do we actually mean by modern? And really, I guess for me, we're talking about the last, 50, 60, 70 years. And the reason I've kind of chosen that is because that's really the time when, first of all, technology has really come along, and technology can be both helpful but also a hindrance for the brain. And also there have been very dramatic changes in our lifestyle over that period of time that perhaps, again, have harmful effects. So I really wanted to sort of just open a discussion up about whether living in the modern times is actually a good thing for our brain or a bad thing. Talk about that. The next thing is when we talk about brain sort of function in general, we're either talking about neurodevelopment or neurodegeneration, and the two are quite different. Neurodevelopment is obviously when the brain is developing, and make an argument that the brain develops throughout all of your life, and I'll come on to that in a moment. But really, mostly what I'm going to be focusing on today is the neurodegenerative side of things. So what happens is you get older, what syndromes you experience that are pathological in nature and so on, rather than sort of classic neurodevelopmental things, which are some sort of ADHD and so on. Another issue to consider is the whole sort of outsourcing thing. So with the advent of technology, that probably is the case that we don't need to remember so much data, we just need to be able to find where it is. We don't need to kind of really work on orientation and sort of finding our place around the environment, because we have GPS machines and things like that as well. So again, that might be helpful, but it can also be a problem. Then we talk about the aging effect on the brain, and there are changes, and we'll come to sort of think about that a little bit. So average lifespan in this country is 81 for men and 85 for women or thereabouts, and certainly age is the biggest risk factor for neurodegeneration. And trying to understand the difference between what to expect in a healthy aging brain versus a degenerating brain is important to try and understand. Then there's this sort of question of what normal and optimal, and I think they're quite different really. What should we accept? And there is this acceptance to a degree about the impact of aging on the brain, but should that be the case? And I think that's an arguable topic, and I've certainly seen people, in their late 90s who are sharp as a tack, so it's not inevitable that everybody's going to have some sort of negative effect of aging on the brain, but it is the norm. So some discussion around that's quite interesting. Then we'll be talking about dementia, which has really been rebranded as this thing called major neurocognitive disorder, in part to sort of try and address some of the stigma that's associated with the term dementia. And then this sort of idea of the aging population, and we're all living for longer. Many metrics of our health are improving, allowing us to live longer, such as vascular disease and so on. But we have less control over the health of our brain. So if you have to think about things in a really pessimistic fashion, we could potentially live for a very long time but our brains are really a problem for a large period of that, so our brains make sure what are we really aiming for. Okay, so just a bit about basic anatomy of the brain and its function as it pertains to cognitive function. So there are 4 lobes on either side of the brain, and they're joined by a thing called the corpus callosum, which is this bundle of nerve fibres that allows communication between the two. The frontal lobe here, I think, is probably the most interesting lobe of all, and really it's the frontal lobe that's most developed relative to our body size compared to other species, and in many ways it's what allows us to be human. So it sort of governs things like our ability to plan, to organise ourselves, to act in a socially appropriate manner, not to act on impulse, and it largely sort of underpins things like motivation and personality formation as well. So obviously a very sort of critical function, allows us to override a lot of the other things that can go on at the deeper level of the brain. Then you have the parietal node, which again has numerous functions, but particularly of relevance for calculation of maths. And also this thing called praxis, which is the ability to manipulate objects, know how to manipulate objects we might have like this. It's a practice that I'm kind of using at the moment to understand how to use this particular gadget. And also for visual-spatial skills as well, so critical things like driving. Then you have the occipital lobe, which is at the back of the brain, which is really for processing and understanding visual stimuli. So you can have an occipital stroke, for instance, where you're still actually getting stimulus going through, but you can't recognise what it actually is. So the occipital lobe is required to interpret that so you can understand what it is. And then the temporal lobe, which is particularly important in memory encoding, and I'll come on to this in a bit more detail, but in your typical sort of Alzheimer's disease, later onset variant, it's the inside of the temporal lobe, or the medial temporal lobe, and in a particular area, the parahippocampus, hippocampal area, that becomes affected quite early on, which means that we fail to put memories in our brain to get that later retrieval. And the temporal lobe is also very important for orientation as well, so knowing where we are in time and space. So that's all the cortex. And then below that is this thing that we call subcortex, and that has different functions, and I'll come on to that just now. So these are some of the subcortical structures. So you have the amygdala, which is your fear centre, you're probably quite familiar with. The cerebellum, which is more to do with movement and also emotions as well. The basal ganglia, which are implicated in Parkinson's disease, so they're very important for sort of movement, and the various other structures as well. And then there's the hippocampus, which is sort of roughly grouped with these subcortical structures. And just to talk about this particular structure for a minute, so this is of particular interest, as I say, in Alzheimer's disease. We first knew about the relevance of hippocampus for memory many decades ago, when a chap who had surgery for intractable epilepsy inadvertently had his hippocampi removed and failed essentially to kind of remember anything new from that point. So his memories from before the hippocampus was removed, were reasonably intact. He could tell you about his early life and so on, but he could not remember anything going forward. So there's a chap called Henry Mollison. So that sort of gave an indication years ago that the hippocampus was important for them. So a couple of things I guess to point out. So the hippocampus does shrink with age naturally. There's some variation from person to person, but we do expect some reduction in volume as it goes on. And as I mentioned before, it also shrinks with Alzheimer's disease as well, to a much more considerable degree, and generally earlier as well. But the positive thing about the hippocampus is that there is some malleability. We can actually have an influence over the size of our hippocampus as we age. And there are various things that can do this. I think probably the most important thing of all, in my opinion, really is exercise, physical activity. And physical activity induces the production of this molecule called brain-derived neurotrophic factor, or BDNF, miracle growth of the brain, as it's commonly referred to, which is really important for neuronal health and growth and so on. And the hippocampus is one of 3 areas of the brain that can continue to create new neurons and new connections throughout all of your life. So exercise is sort of a critical part of it. If you're depressed, which is often associated, again, interestingly, with shrinkage of the hippocampus, and depression is also associated with low risk of dementia. I'll come on to that. Then if you give somebody antidepressants, then the hippocampus also increases in size as well. Meditation, stress reduction can help with hippocampal volume and function. Dietary interventions, there's some correlation between omega-3 fatty acids that you might get from oily fish and things and hippocampal volume. If you have sleep apnea, which is a very under-recognized condition, and then you treat that, that can also help with the shrinkage of the hippocampus. And then using your brain, and particularly for things like spatial navigation, seems to be particularly helpful as well. So that you may have heard of the London cab driver study, which was about 20 years or so ago. And this is before the era of GPS, when cab drivers in London were expected to pass this test called the knowledge, which is very intensive visual mapping. They have to look at where all the streets are in London and be able to tell the examiner how to get from A to B, one side of London to the other. So very intensive kind of work. And they found that London cab drivers, their hippocampi was significantly larger than your average person who didn't have to go through that test. Then they had the cab drivers actually retire, and the hippocampus actually shrank back to average size. And then a few of them said, I'm going to go back to work, and the hippocampus grew again. So there's this real plasticity of the hippocampus, which is, I think, quite an optimistic thought.
You mentioned exercise and that spatial navigation. Is there any particular kind of exercise that's been, found to be more beneficial for this prevention of the reduction of the hippocampus? And the other thing was, should I rely on my GPS less? And like old school.
Yeah, the second question, yes, you should rely on it less, I would say so. And it's good to have it there as a backup, but I think you should always give yourself a chance to get from A to B without it. And then the other thing a lot of people recommend is taking unfamiliar routes. So you know A to B, and you normally follow a certain route, take a different route. Consistently take a different route, because you're kind of exercising that side of things. In terms of the types of exercise, so we recommend all different types of exercise, both in terms of aerobic and resistance training, anaerobic. I think thoughts are probably aerobic exercise is going to give you more bang for your buck, but resistance training is important, and I'll come on to why a little bit later on. And then there's also interesting research about different intensity of exercise. So high intensity exercise might be particularly helpful, and that sort of lends itself to this kind of more general concept that if you put the body under a certain amount of stress adaptively, what we call hormesis, it can favourably respond. So we talk about mixing it up with your exercise, both doing anaerobic, aerobic, high intensity can, but also there's interesting research around doing what we call zone 2 training, which is where you're actually going a little bit more than you would if you were just going for an amble. So a brisk walk will get you to zone 2 training. There's kind of specific parameters at a certain heart rate that you aim for, and it's a lot lower intensity, and that might have particular benefits for the mitochondria, and mitochondrial health is one of the things that I'll mention in a moment that might influence dementia later on.
Thanks.
Okay. So when we look at a microscopic level, everybody would be familiar, I'm sure, with your neurons. So this is the neuron here. So basically everything that you do really is underpinned by transmission of messages from one neuron to the next. And so they travel along this thing called the axon, which has got this myelin sheath, insulated sheath, like a wire around an electric cable, if you like. The message travels down to the other end of the neuron, to the axon terminal, and then from there it gets sort of converted into a chemical as it enters the synapse, and then the synapse is a gap between that and an adjacent neuron, so it travels on to the next neuron, gets pent up as a chemical message again, and then travels on as an electrical message, and so on and so forth. So that's the basic function of neurons. We have a huge amount of them. I think they've estimated there's 5,000 kilometers of neurons, and kind of put them all together, so they're tiny, they can be a meter long, but as a network, they're huge. Trillions of connections between them. It's the old sort of cliche, more neurons in your brain than stars in the galaxy, that kind of thing. So they're innumerable, really. What we are now concentrating on more is the other types of cells in the brain, so what we call the neuroglial cells. So there's 3 main types: the oligodendrocytes, the astrocytes, and the microglia. And these are pivotal in supplying energy to the neurons. so nutrients and so forth, and they're also really important in mediating inflammatory response. And I'm going to talk a little bit more about inflammation in a minute, because I think that's one of the kind of hot topics when it comes to brain health and dementia. So we're looking more and more at the role of the glial cells in inflammation in neurodegenerative disease and even in aging. Okay, so just a brief discussion on what happens when we're actually trying to memorize something. So there are different types of memory here, and this kind of diagram is more related to the sort of top memory, which is explicit memory, which is the sort of memory that you can kind of consciously recall, and we generally sort of divide that into this thing called semantic memory, which is our knowledge of facts and figures and so on, and then episodic memory, which relates to the episodes you've had in our lives. And you can have specific types of dementia, like semantic dementia, which is a frontotemporal dementia, where you have no problems with your memory, but you just simply can't pull the words out for what you're seeing. So explicit memory sort of follows a certain process, and I've really put this up in part to show that different parts of the brain are all responsible for actually getting to a point where you can recall a memory that's embedded. So you get some sort of stimulus, whether it's a visual stimulus or something you hear or whatever, that becomes a sensory memory, which is incredibly brief. To then, for it to be any more, to be taken into any more degree, you then have to pay attention to it, and attention is often actually a thing that goes wrong, and people don't have a memory problem as such, they're just not paying attention. And if you don't pay attention to something, you're not going to then be able to memorize it in any way. It then sits in, I guess, the frontal lobe of the brain for a while, and is a controversial term, but is thought to be this thing called short-term memory. And we also have a concept of working memory, which is more of an active element of short-term memory, where we're trying to hold bits of information in hand and then use them. So remembering a phone number, looking at a shopping list and then walking around a shopping centre and trying to memorise what it is that you've got popped down there. So that's all really controlled by the front part of the brain, predominantly, directly or indirectly. Then you have to encode the memory, which is really a pulling together of the different parts of it. So, where you were when you had the memory, what you saw, what you heard, what you smelled, etc. And when the hippocampus is damaged, this is the problem that arises. So people with Alzheimer's disease, their problem is one of encoding. And so, however much, and there's a gradient of this, but the general importance of the comment about that is that if you don't encode, the information's not going to go in. So it cannot be related, to the tree. And so, from a day-to-day perspective, if you're looking after somebody with Alzheimer's disease and you're just continuously harassing them, I told you that, can't you remember that, etc., that they probably can't because it never actually went in there. In other types of dementia, such as vascular dementia, it's this issue here, retrieval, that's the problem, and that's slightly different. So memory needs to be encoded, to be put into the brain, and then it becomes long-term memory, which we don't, to be honest, really understand very well, but we think it's kind of distributed in the cortex in various different places. And then to bring it to mind later on, we have to retrieve it, and in things like vascular dementia, this is where the problem is. It's a bit different than Alzheimer's. Vascular dementia being related to blood supply. So it's getting the information out that's the problem. It's gone in, but it's putting it out that's the problem. And we all experience this issue as we get older anyway. And I'll come on to this, but I guess it's the extent of it, so that dementia is present. So that's the basic kind of way that the brain creates and stores and then brings forth the memory again. And the other interesting thing, I suppose, about this encoding and retrieval issue is that with Alzheimer's disease, I would often see people that will come to see me and they'll say, well, I can't have Alzheimer's disease because I remember things from 50, 60 years ago. And unfortunately, that doesn't mean they don't have Alzheimer's disease, and that's quite typical. It's what we call a temporal gradient. And that's basically because the information from 50 or 60 years ago has been encoded when the hippocampus was healthy. More recent memories, which have theoretically gone in or not gone in, are occurring when the hippocampus is faulty. So that's the issue there. So people often remember things long ago, but don't remember what it is. And so the other type of memory, just briefly, is this thing called implicit memory, which is more to do with procedural autopilot things, riding bikes, driving a car, that kind of thing. And that tends to be, in general, a lot more robust in things like dementia. So you can have very limited memory of what you did that morning, but you might still be able to drive okay because it is a sort of deeper part of the brain responsible for that. And people that have a thing called highly superior autobiographical memory, so these are very rare people. There are some, I think, being studied maybe in UQ. The kind of people that can remember pretty much everything that's happened in their lives. They seem to have particularly good connectivity between the front part of the brain and then the hippocampal area. So there's lots of evidence to suggest this is how the process works. All right. The other thing, I guess, just when I talk to people about dementia is at times we will diagnose somebody with dementia, but they don't actually have memory problems. And I draw attention to the fact that there are actually lots of different cognitive functions. So memory is obviously an important one, but there are all these other things that can go on. So we talked about attention, orientation, and praxis. Gnosis is kind of the ability to recognise something, and it can be tactile gnosis, which is, I close my eyes, something puts this in my hand, I can tell you what it is. Or it can be visual gnosis, kind of recognising what you're seeing and so on. Visuospatial function, calculation, and executive function, which is that front part of the brain again, so decision making, planning, impulse control, emotional response, and so on. So dementia can actually affect different parts of cognition, not just memory. All right. So the next few slides are just really about, I guess, almost a gradient of issues with the brain. The first being, as I say, normal aging. Whether optimal aging, as I say, is a different matter. But what we normally expect to happen as people get older is that the most obvious thing is this decline in processing speed. So I was talking about retrieval before. So this is word finding difficulty. So classically, not just bringing the word to mind quickly enough, and then the moment passes and it comes to you a few minutes later. That's classic word finding difficulty, which is probably related to this processing speed. So everything just takes longer to kind of pull out. Thinking is more slow. My son and I had a competition, one of these fastest finger kind of thing, some general knowledge quiz, and he's 17, and I just think it was terrible. So don't try things like that if you're getting older. But the thing is, the information should come to mind with time. It's just that it's slow to pull out. We do also see some decrement in memory, which I mentioned, and that's probably because the hippocampus shrinks a bit. And then the other area of the brain that seems to be particularly prone to aging is the front part of the brain again, which causes those problems with executive function. So that might be, in this case, paying attention to things and being able to switch from one task to another. And we do tend to, it seems, get a little more rigid as we get older in our thinking, and that's probably part of the kind of executive issue that arises. We don't normally expect any major change in language function apart from just a slow retrieval with word finding or vocabulary or visual spatial skills, and our general knowledge really should increase as time goes on. Just with that caveat, might be a bit hard to pull out. And the other critical thing about normal aging is that you really need to be able to compensate. If you can't compensate for these issues, then that's when I start concerned that something else might be going on. So this might be using diaries or calendars, or just giving yourself more time to remember things, not being so distracted when you're trying to put the information in, etc.
So I just have a quick question about the retrieval problem.
Yeah.
Is it possible that an older person just has more stuff to go through to retrieve a particular piece of information, and a younger person, just doesn't know that much?
That's an interesting question. I think the brain intrinsically is actually really good at pulling out. You can have. I think it's a bit of a fallacy that your brain kind of just gets too full and things. I think it's thought that we actually have this kind of limitless capacity for remembering things, really, in theory. So having more information in your brain, generally, I'm not sure. Having said that, if you've got a lot going on in your life at any one point in time, so I'm setting up this memory clinic, I've got 3 teenage kids, I've got all this kind of stuff going on, then that means that it's harder for me to retrieve it because my mind is elsewhere. But yeah, I'm not sure that we can say that because you've had more memories later in life, that makes it hard to retrieve specific ones. Interesting point. Okay, so beyond normal aging, we have these conditions called subjective cognitive impairment and mild cognitive impairment. This is really when somebody says, my memory's not good or some other issue, but when we test them, they're actually pretty good, and that can be due to various things. Mild cognitive impairment is the next level up, and that's really where, again, there may or may not be complaints of memory concerns or other cognitive issues, but when we test them, there is a mild degree of impairment, but it's not impairing function day to day greatly, so it's not what we would call dementia. I'll come to the definition of that in a minute. This is a really important thing to pick up. This is actually quite common as we get older. Sometimes it can be due to things that are reversible, like depression, anxiety, medication effects, sleep apnea, things like that. But it does carry with it an increased risk of going on to dementia. And the thought is that probably when you reach about the age of 65, the chances of getting dementia may be in the region of kind of 2 to 5%, and then they sort of double every 5 years or so. With mild cognitive impairment, year on year, there's about a 12 to 15% chance of actually developing dementia as you get older. So it's it's very important to pick up because it's not dementia yet, but it is a risk factor. And the other importance of picking it up is that there's now research being done to suggest that there are things that may reduce your risk of going from this to this. Again, exercise is one of those things. Dietary interventions may be helpful, and using your brain for complex mental activity.
Just one question from the back view. What about Scrabble? So someone in my family suffered dementia. I wonder if something like Scrabble would help them. They like reading magazines and that sort of thing.
Yeah, so I think with complex mental activity, the critical thing is novelty. So if that person has always played Scrabble, they're probably not going to get much out of it.
They haven't.
Okay, so if it's something new, then that's probably a really good thing.
Novelty.
Yeah.
Okay.
So novelty's a thing. The classic is, are you a crossworder or a Sudoku? And then if you're one of those, try the other one. So doing something different with your brain, making it mildly stressful. So it's got in the same way that if you go to the gym and you're trying to increase your muscle mass, you've got to push yourself a bit. You do with the brain as well. I guess the difference with that analogy is that you can definitely overdo it with your brain stress. And I've seen lots of people that get completely obsessed using phone apps to try and exercise their brain, and they're all progressive and you can track how you're going compared to other people, and then they get in this obsessive loop about whether they've done it and how they're going, and I think the stress in itself is really problematic for the brain. So the overall one's a sort of negative situation.
Does that mean that anything at all that you do, for example, if you stand on one foot while brushing your teeth, if you don't normally do it, so any novel action, whether it's physical or mental, is going to increase brain capacity?
Over and above things that you do on, I guess, autopilot, theoretically. I think the more you can incorporate different senses and different activities into complex mental activity, the better. So that's not a bad example, I suppose, of using a couple of different things. Use sort of balance and all the rest of it.
Brush your teeth with the opposite hand.
Brush your teeth with the opposite hand. Things like dancing, learning languages, playing music. There's specific evidence that all those things are helpful. Dancing is particularly interesting because what you're doing often is socialising, which is healthy for your brain. You're moving, which is healthy for your brain, and you're really having to engage your brain to coordinate yourself as well. And then there's a sort of emotional element of it, which may also be relevant to memory. So theoretically, any new thing is good for your brain, whether very specific tasks are better than one another, over and above, dancing, music, and languages, I'm not sure. Delirium, I won't dwell on this, but that's really just another word for an acute confusional state. So really, by definition, it's something that's reversible, but we see it a lot. I guess the other important thing about that is if you do have somebody that goes into hospital with a delirium, then often it can be the thing that uncovers the delirium from your mind. Okay, so then we talk about dementia itself. So this, as I said before, is also known as a major neurocognitive disorder. This is according to the DSM-5, which is a guidebook for conditions. It's a syndrome and it's not a diagnosis, and this is something that most people actually don't really appreciate. You can't really be diagnosed with dementia. You should be diagnosed with a form of dementia. Dementia due to Alzheimer's disease, dementia due to vascular disease, and so on. So it doesn't actually tell you what's going on. All it really is telling you is that there was some cognitive problem at to say. That's often memory, but it can be language, it can be social skills, other issues, and that cognitive problem is actually causing impairment of day-to-day function. So it's a noticeable deterioration in ability to cooperate. And implicit kind of in the diagnosis is this idea that with dementia, it will get worse with time. So, dementia prevalence, probably not surprised to hear that age is the biggest risk factor, and this is Australian data, I think. And you'll see a couple of things. So you can see the general uptrend as people get older. You can also see that females have a substantially higher proportion, particularly in Alzheimer's disease. And there are reasons for that. It's a little controversial. Maybe hormonal influences. We know estrogen's good for the brain, and then when females go through menopause, or if they have early menopause, surgical menopause, that may be a risk factor. Men tend to continue to produce testosterone to a degree throughout their life, and that testosterone gets converted to estrogen in the brain. So they're kind of protected. But it's not
this graph, like 85 and up, like women, there are more women in that population. It's not this number of people, right? So there are like way more women that are 85 and up.
Yeah. So there are
younger age groups and stuff like.
I mean that's a fair point. I mean there's more women that live older than men, but even taking that into account.
Could it also be that their husbands are all dead by then? Because if all the guys are knocking off at early 80s, it's after that women that don't have a husband, don't have a partner to talk to, they're maybe responsible.
Yeah, it's possible. Although I did
stimulus or something.
Yeah, it might well be, and I do remember hearing something that women that have the worst health are married women, and the men that have the worst health are the single men. So actually possibly being single as a woman is better be healthy. But jokes aside, look, I think not having a partner, the issues of grieving and loss, all of that kind of stuff could certainly account for some of those things.
But isn't it also that women, by and large, go to doctors and seek health professionals much more than men? Don't think I'm not being sexist here, but it's just women have children and things like that. So.
Yeah, women are more likely to come to the attention of medical professionals and then be diagnosed with a form of dementia, so that may be part of it. Interestingly, you talk about children and so on, because another thought about the gender difference is simply because of women's roles in life being perhaps more stressful, and certainly there's some research to kind of back that up. So that we don't really know. We know it exists. We don't know why, but there's kind of these hypotheses around it.
Just curious about what you said about the controversy around hormones and dementia. Can you say a bit more about that? Are the studies inclusive or?
Yeah, basically. So I think that, and it's one of those areas where there's a lot of zealotry. So there are some people that are really, saying that everybody that goes through menopause should be on estrogen to protect their brain, and then you have other studies that suggest that it's not actually that beneficial and there's too much risk associated with it. So we just have incomplete evidence, basically. I don't. It's a tricky one. The general guidelines that we follow suggest that we shouldn't be using estrogen for the purposes of protecting your brain post-menopause. It's yet to be known for sure.
This is from an Australian study. How about in other cultures? Is it the same sort of thing that women are more likely to?
I believe so. Yeah, I haven't heard anything to the contrary. That,
I'm wondering, looking at the graph, what is easy to see is that at the age of about 80 or so, the lines are about the same. Then suddenly, women take off. I wonder whether it's got to do with lifespan and health span, that the man, in order to get old, needs to be sort of generally healthier, all up. And that will also help the man, to reduce the risk for dementia.
Yeah, that's actually one of the other thoughts, that men who traditionally have worse vascular health, if they're surviving till this age, they're generally healthier. Yeah. And one thing that we do actually know is that one of the risk factors for Alzheimer's, the most common cause of dementia, is vascular disease. So this is kind of interesting interface. So that may well be another explanation. Yeah. Okay, so I hope you can see this okay, but this is the, I guess, relative prevalence of the causes of late onset dementia, by which mean dementia that develops after the age of 65. Alzheimer's disease is kind of accounts for about 2/3, and we have vascular dementia, mixed. I think a lot of people say this is actually more, so mixed is generally a combination of vascular and Alzheimer's. But you can have Alzheimer's and Lewy body disease together as well. And the older you get, the more likely it is you're actually going to have some kind of mixed picture, to the extent where people actually refer to somebody who perhaps has manifest clinical dementia in their sort of late 80s to 90s and then pass away and you biopsy their brain. If all you can find is the Alzheimer's pathology and nothing else, that's referred to as a unicorn. So it's actually very, very rare. When you're younger, it's more likely you're going to get maybe a single pathology, but certainly as you get older, you're likely to have both. So Alzheimer's, vascular, Lewy body, and Parkinson's disease dementia, these are quite similar in the sense that it's the same protein, something called alpha-synuclein that accumulates, but just in sort of slightly different parts of the brain. Frontotemporal dementia here is another common one as well, which affects, not surprisingly, frontal part of the brain from the temporal area. What they don't have out here, interestingly, is alcohol-related dementia, which actually is quite a substantial feeder of dementia as well. We'll talk about that in a moment. But in fact, we've got hundreds of causes, and there's just kind of, I guess, half a dozen or so account for most of them. Current prevalence about 500,000 in Australia, and they've probably double that if they have that mild cognitive impairment, and 50 million people worldwide, and those figures are set to double or treble, particularly in the developing world. So it's going to be a huge problem. Leading cause of death in females, second leading cause of death in males. So at a societal level, it's a real issue as well. Okay, I don't know, is anybody familiar with this infographic? Have you seen this before? So this is, hopefully you can see it okay. This is from the Lancet, and if anybody's kind of interested in looking at the so-called modifiable risk factors for dementia, there's a great Lancet article from 2020 that basically tried to go through all the really good quality evidence and double-blind randomized control trials and pull apart how many of the different cases of dementia could potentially be delayed or prevented by addressing modifiable risk factors. And they've kind of given this lifetime continuum, and they've identified issues at all these different ages, later life, midlife, and early life. To be honest, I think there's a lot of blurring between these things. Although it says smoking in later life is associated clearly if you smoke from the age of 20, it's going to be a problem. But in general terms, I think the important things to notice are that from an early age, it's important to kind of be aware of what may be modifiable, and then also in late life, there are still things that you can do to help. So education is clearly important, and this comes to this sort of concept of cognitive reserve, which is the ability of the brain to compensate for the physical damage that might be caused by the dementia. And we know that people that are more educated are protected to a degree from those clinical symptoms of dementia. When they do get dementia, it then seems that they may deteriorate more rapidly, interestingly. And maybe that's because by the point they've reached that clinical diagnosis of dementia, they've got a lot more of the burden of amyloid tau proteins and Alzheimer's in their brains, and the decline is more rapid. The other interesting thing here is hearing loss. So a lot of people don't think really about hearing loss as a risk factor, but if you look at all the different figures, from the population level, there's the biggest risk factor of all. So if you can sort people's hearing loss out at the population level, that's probably going to prevent or delay more cases of dementia. Yeah.
Can I just know, would tinnitus, for example, be a sign of the brain having difficulty in dealing with hearing loss? And maybe an indication of potential future.
Yeah, I actually don't know about tinnitus specifically. I guess we still don't quite understand the link between hearing loss and dementia risk.
Yeah.
So some people say that it may be the same pathology that's causing the hearing problems that's causing the dementia, so it's the same kind of damage at different areas, if you like. Some people say it's the social isolation that people with hearing loss might suffer, and sort of, I guess, the anxiety and depression that may come with that. And then there's a thought that because you're not hearing so well, and this may relate to the tinnitus issue, you're having to use more of your processing, if you like, to focus on interpreting what you hear at the expense of other parts of your brain. So you're not exercising the other parts, and therefore there's a problem. So, yeah, so I'm not sure about tinnitus specifically, but there's different thoughts about that.
So it's an association, it's not there's no causality.
Yeah, so we can't assume that there's an association between the two things. There is evidence to suggest that if you correct people's hearing with hearing aids, that then reduces their risk of dementia. So if it was just a shared pathology, that probably wouldn't happen. But there's methodological issues.
Sorry. I'm just wondering how about having a purpose in life later on as you get older. That's a factor too.
Yeah, look, I think that's a huge factor.
Just this doesn't appear, maybe it's connected to depression, maybe it's social isolation.
Yeah, well, the commission group that actually sort of did the study, they really just looked at the very sort of gold standard tests, if you like, or the studies that actually show. So this is not going to be exhaustive by any stretch.
So this relation, having contact with younger people, what I see in our society, very different, for example, from Indonesia, where I lived on and off. But in ours we tend to put people in, where they live with other old people. There's no interaction with younger generations, etc.
Yeah. What we know is social isolation, which is sort of picked up there, is certainly seems to be a risk factor again for dementia. And we also know that social isolation is associated with increased inflammatory markers on blood tests, and there seems to be some link there. So we'll come on to talk about chronic inflammation, but anything that kind of causes stress and therefore inflammation may be a risk factor. A lack of meaning and purpose may follow the same route indirectly, but certainly I think pretty much in all health metrics, meaning and purpose is a really protective thing.
In your experience, is there a positive case study from somewhere, like you mentioned Indonesia, is there somewhere that's like they have low rates of dementia that they seem to have some correlation to this or association?
So there's some data that in Japan and India, maybe the rates of dementia are lower, and we don't exactly know why that is. Some people think it's related to diet, but it could be a cultural thing. Japanese people that then move to Hawaii lose that benefit in terms of dementia risk. And the idea is that maybe it's because their diet becomes more of your standardized American diet, which is really terrible for your brain. But I'm sure that, whether it's meaning or purpose or connection or being part of a community, I'm sure those things are all very protective, actually. It's just that they're hard to study. And you'll notice on here, it doesn't say anything about diet. So that's another big thing that's missing. It doesn't say anything about sleep, I don't think, which is another big thing as well. So it doesn't include everything, but it's what we know so far. And the Lancet Commission did a similar thing about 2016 or 17, and they said that 33% of cases could be prevented or delayed. They were repeated in 2020, and now they're saying 40%. So it's kind of going up as we're getting more evidence. So this isn't a static thing; it's just what we know so far. But if you think about those figures, so you've got 50 million people sent to travel, so potentially another 100 million, and 40% of them are potentially on the farm over the next 10 to 20 years. It's huge. Any questions about that? That's quite interesting.
There was just something else I wanted to ask about social isolation, because people with autism are not likely to suffer in the same way from social isolation, because it's likely to be a more desirable aspect of life. Yeah. So is there evidence that people on the autistic spectrum actually suffer from less dementia affected by social isolation, or evidence of that?
I'm not aware of them being protected against dementia, but it's an important point to note that actually perhaps not, although they talk about social isolation here, it's actually more about the feeling of loneliness rather than social isolation. So if you're surrounded by people that are feeling disconnected from a meaningful interaction, then you can still feel lonely. On the contrary, you can have people who don't really need many friends or whatever, and they're perfectly happy, they don't have a particularly good social group, they don't feel lonely, they're fine. So it is probably more of a psychological effect, and evidence suggests that's probably more of a potent factor than the actual number of kind of social connections you have.
Why evolution is also not
Sorry, I missed that.
why evolution? Frequency evolution
Yeah.
is there?
Yeah.
Why?
So yeah, that's another interesting topic, and I guess the obvious kind of explanation there would be that people that live in polluted areas have lots of other variables that are at risk for
It's
brain.
not really independent.
Well, I think again we don't know. There's definitely some suggestion that the actual pollution itself, whether it's polyaromatic hydrocarbons or so, actually do have a toxic effect on the brain. There's this sort of gradient effect. I think there was one study where they looked at people who live 50 metres from the main road versus 300 metres from the main road, so this kind of gradient of increasing cognitive impairment. So again, it's we don't know for sure, but I think there's certainly some fairly direct evidence that pollution and the molecules that it causes actually do have a directly deleterious effect on the brain. Might be other areas.
So is any, just with the air pollution side, is there any connection between the use of leaded fuel and that? I mean, it's certainly, I mean, I was younger that everybody used leaded fuel.
Yeah. There's definitely a link between lead, any sort of heavy metal kind of excess in blood, and brain difficulties, generally speaking. So you certainly know lead can affect your brain at all kind of ages. I don't know whether the amount of lead in leaded petrol would have been particularly relevant, I'm not sure. But yeah, when I do testing in memory, that's one of the things we always check. And I've had a couple of people who have had high lead levels and things. So it does occur. But sometimes they can be sort of slightly elevated. I really don't know what to make of that. So
these things seem like they may possibly affect normal aging as well, like the normal healthy aging brain. And I wonder whether things like social isolation, lack of physical inactivity especially, I can imagine, would influence the normal healthy aging brain. And I'm wondering if you know, just do these things modulate the person with dementia or Alzheimer's more than the normal healthy brain, or is this just an overall sort of decrease in changes?
yeah, that's an interesting question. I think you can have a brain that's vulnerable to dementia for whatever reason. They have more amyloid tau in their brain for some completely different reasons, say genetic. And then these factors don't have much of an effect on their brain than they would if you have otherwise healthy brain.
Right.
Yeah. We also know that the whole is greater than the sum of the parts. The same. So you have 3 or 4 different risk factors that kind of cumulatively are much more of an issue. So the way that I see it is kind of like a stress vulnerability model. So if you have a vulnerability for whatever reason, and you add in something else that's stressful to the brain, it's going to have more of an effect. And, I guess the other thing is how you separate these things out sometimes. Somebody who's physically inactive may well be more depressed or may cycle.
And these are all going to be correlated with aging itself, I'm assuming.
Yeah, that's right. So, probably worth just having a chat about alcohol, because for some reason everybody seems to be interested in knowing. Oh, sorry, you go ahead.
Just very simple question. Is it reversible when it comes to dementia? Can it be controlled or is it reversible?
Yeah.
That's and the other thing is, what's the proven symptoms? There could be, or if the symptoms are exactly the same in everyone, or could be different.
Okay. So the first question, I suppose, really when you have dementia, generally the idea is that it is not something that's curable. Otherwise, it might be a sort of delirium or something along those lines. There's some new medication out which perhaps clears amyloid from the brain, and that might help with dementia. That's kind of in America, it's very controversial. I can talk about that a bit more if you need to, but the general idea is that it's not something that you can cure. It's progressive at this particular point in time. In terms of the symptoms you present with, so that really depends to a degree on what the cause of the dementia is. So Alzheimer's disease, the majority of cases as you get older, typically presents with that difficulty in coding. So as I say, they acquire new memories. Vascular dementia affecting the blood supply, it hits you. Your frontal lobe, you're going to have more problems with planning and impulse control, maybe less memory issues, or retrieval might be affected. Frontotemporal dementia, you can either have language problems or behavioural problems. So there's a whole spectrum of different symptoms that you can encounter. Yeah.
No, the reason I asked that question was, there was a time when I had very clear cut in my mind something that, okay, I'll go and get this. By the time which is sitting in the refrigerator, something, when I went there, why I was there?
Yeah.
So what's that?
Well, as an isolated thing, that's not dementia. So that's really that's really quite common. So whether that's a sort of minor deficit of memory or whether it's just that you're not really paying attention to what you're doing.
Straight away you get from someone, right? You are having dementia.
Yeah. It's probably an overdiagnosis.
The first thing I'd ask is, are you high? That's not chance of dementia.
Yeah. Or how much have you had to drink?
I can concentrate more when I'm high.
There has to be some confirmation bias or something going on as well, where you get older and you forget something and you tend to attribute it to getting older, whereas you do the same thing when you're young and you don't think
that's so true, and I see quite a lot of people in their 40s and 50s who are actually fundamentally quite healthy, but they have hypervigilance. So they're actually doing exactly what they did in their 20s when you go through it, but in their 20s it's all just a bit hungover or like stressful. In the 40s and 50s, they think, oh my God, this is dementia. So they're being quite right.
So you mentioned genetics. If you have a family history of dementia, what is it like to live with dementia?
Okay. Yeah, I can talk. Do you have a slide on that? But we'll come to that. Yeah, that's important.
So, have the studies been done for the early dementia and a lot of younger people are getting dementia now? Are the risk factors still comparable? Because I've noticed that quite a bit. I'm not sure. I think it's like more of the brain function, some of these factors. So maybe it's because we're not using our brain to the same capability that we were.
Yeah. Yeah, I mean, I think some people believe that younger onset dementias are sort of almost like a different entity in a way to your typical later onset dementia. And it might be that one of the problems or the difference is that in younger onset dementia is that you get overproduction of amyloid, the proteins in Alzheimer's, whereas when you get dementia later in life, you're clearing it as well. Sleep being one big way to clear it. So there's probably something different in the pathophysiology of it. When you look at the graphs of the prevalence of dementia, late onset versus young onset is thought to be quite static. So I don't know that we have a sense that the numbers are really increasing with that, whereas with late onset they are.
I have a question up.
Physical inactivity, shouldn't that apply for midlife too? Or is it a contribution less for dementia than in later life?
Yeah, look, I think that's a good point. And as I said, I think there's blurring between these things because I said before, if you take up smoking in your 60s or 70s, you're probably less of an issue than if you continue to smoke in your 60s or 70s and started in your 20s. So there's some kind of controversy about some of these things. But, I mean, a lot of them, I think, really apply across the board to a degree. But I guess this is how they've shown that they've kind of separated them out based on studies. So it might be that they just have better evidence suggesting that late-life depression is a risk factor rather than midlife depression. But I suspect, if you did enough research, you'd find that midlife depression is a risk factor too. There's probably something to do with the way the studies are being conducted. And as I said, this is not exhaustive. I think there's a lot of other stuff. fact that the diet is not in here really astounds me, but it's because most of the studies that are done on diet are kind of observational in nature, so it's actually quite hard to get that, what we would see as the gold standard evidence, but everybody recognises that diet has a profound effect on your brain. Okay, so genetics. Late onset, so above the age of 65. I guess the most well-studied gene is this thing called the ApoE gene, or the apolipoprotein gene, and it comes in 3 variants, 2, 3, and 4. And if you have 1 or 2 of the 4 variants, so you get one from your mum, one from your dad, then it increases your risk of Alzheimer's disease. So if you have 1 ApoE4, your risk is doubled. If you have 2 ApoE4, then it goes up by 12 to 15 fold. So it's quite substantial. Having said that, because of all those other modifiable risk factors, I think if you do have these risk genes, you should really be alert and not alarmed, because I think a lot of the other things may have equal relevance to risk. So this is probably the most well studied. There are others. There's actually probably dozens, possibly even hundreds of different genetic risk factors, but including TREM2, but ApoE is the most studied, and that's been studied for the last 30, 40 years. One of the ways that might cause Alzheimer's disease is through that inflammatory process that I was talking about, and it's quite interesting. They think that when our ancestors were kind of roaming the savannah, most of them actually had EE4, and that's because people with this ApoE4 gene have better inflammatory responses. So back then in the savannah, the real threat was sepsis. Cut your foot on something, get your arm bitten off by something, infection is going to be the big issue. And so that then meant that this kind of survived, if you like. And generally speaking, people didn't last long enough to then manifest the dementia that would otherwise occur with this. So that's, I guess, another bit of evidence that perhaps inflammation is one of the underlying issues with Alzheimer's disease. It also affects this ApoE4, things like cholesterol metabolism, your glucose metabolism, your metabolism of fatty acids. And so all of that's relevant. And a lot of people don't test for this. You can get tested. It costs about $100. You just get it through QML, SNN. But I do tend to test people because I think there is some research suggesting that if you do have these certain risks, you can tailor advice based on things like you might need to have better blood sugar control if you like, or you might need to increase your intake of oily fish above the average person.
But when would you recommend is a good time to test for it?
Well, the earlier the better in a way, because all of these things that can help with the brain, they're far better off being put in place earlier in life. The only downside to it really is that, it isn't in itself, as I say, predictive entirely of Alzheimer's. 25% of the population have one copy. And some people can get tested and then get really stressed about the fact that they have a risk gene. So I have one ApoE4, one ApoE3, which is neutral. So I'm double the risk. But I guess because I know the research well enough, I'm just vigilant about these things. But you could, of course, get stressed, especially if you get the ApoE4 double. That could be an issue.
Sorry, have you ever come across anybody with dementia that does not have the ApoE4?
Yes, so there's two things there. So yes, you can still get dementia despite not having the ApoE4. And then, again, as I say, you can have the ApoE4 and not get dementia. So, and this is, I guess, specific really to Alzheimer's disease. There can be dementia due to other things which would be completely unrelated to this. There is some suggestion with ApoE4, I think, that it has a negative effect on vascular health, blood supply and things as well. So that might be an increased risk. But yeah, it's kind of, it's neither necessary nor sufficient, but it is one of the risk factors that we can look at. When we look at people with young onset dementia, which is only 5% of the cases, then there are 3 genes, presenilin 1, 2, and a thing called amyloid precursor protein gene variants. And the genetic risk with these is much more substantial. So they're dominantly manifest, which means that you have just one copy of these, either from your mum or your dad. you will develop dementia at some stage should you live long enough. This is not something that I get tested. If you've got a strong family history, multiple family members who have dementia at an early onset, then it's worth possibly thinking about getting tested, but of course that, there's all sorts of ramifications for that. And it's a misconception actually that the genetic risk element of it makes up the majority. In fact, only 5% of cases are actually kind of genetic, of younger onset dementia are related to genetic causes. So most of them are still what we call sporadic. And all these things here, so they affect the production of amyloid, which is what I was saying before about younger onset dementia. So there's a kind of overproduction, if you like, of amyloid. Okay, so unmodifiable risk factors. So we talked about age. It's just some interesting information. So Queensland kind of sits in the middle somewhere in terms of our life expectancy. So 2018 to 20. Average lifespan of female 85. Males almost 5 years less, and then the Northern Territory has the lowest, probably because of the indigenous population, and the ACT has the highest life expectancy. Kind of interesting, possibly predictable, but nonetheless interesting. So the biggest risk factor for dementia and Alzheimer's disease is age, and by the time you reach your mid-80s, certainly to 90, there's about a 30 to 50% chance of actually developing some form of dementia. So it does go up and up. So really, if the average person's kind of living to there, there's a reasonable chance of it happening on average. Okay, so just a bit about Alzheimer's disease itself. So it's been known about, I suppose, or recognised as a term for over 100 years now. I think it was the early 20th century, and this European physician, Alois Alzheimer, presented the case of this lady, Augustita, who actually did end up probably having a young onset dementia. She developed cognitive problems in her 50s, and then after she passed away, he looked at her brain and found these two proteins which still remain the hallmark features of Alzheimer's disease. So one was amyloid, one was tau, and the amyloid, so there's a microscopy of the brain here. You can see these brown patches of amyloid, and they sit between the different nerve cells and can cause inflammation, neuronal damage, neuronal death, and so on. And then tau is another protein which becomes misfolded in Alzheimer's, and that's within the cell. So these kind of black shapes here are neurons or nerve cells full of tau that clearly are dead and not functioning. So these two things are, we do definitively diagnose somebody with Alzheimer's. We still have to say, after they've passed away, they've got these particular proteins in their brain when we examine them. So the other interesting thing, and I guess coming back to how we've progressed, so one of the positives about modern age is that we do have a lot more ability to kind of image things and try and understand what processes are happening. So this is a mock-up of what we would often see on an MRI scan, sort of cutting across your brain like that. And we can see on scans now that the hippocampus that I've talked about a bit is shrunken. So if you have somebody who's got memory problems plus a hippocampal shrinkage, then that certainly puts us in favour of that. Alzheimer's as a diagnosis. We used to talk about Alzheimer's disease being synonymous with dementia, and of course that's what most people think anyway. But we can now identify so-called preclinical Alzheimer's disease. So that's Alzheimer's disease where we think the amyloid and tau are there, and we think they're going to go on to develop the clinical syndrome of dementia, but they don't have the symptoms yet. And I guess the ramifications of that are really quite huge, because if we can understand again when people are having those early neuropathological changes, we may get to do something about it. So one of the things that we can do, and this is research now, in Australia we don't do this generally as a kind of clinical thing, but it's in the research world that's using this. We can do these things called amyloid PET scans, which essentially look at the presence of amyloid in the brain. And you can see here, this is the years before onset of symptoms, so 20 years before, 10 years before, at the time of the dementia Dementia syndrome, and we've got carriers. I believe this was of the double ApoE4, but I could be wrong about that. But this is a high risk group for developing dementia anyway, and then the non-carriers. You can see in a normal brain, non-carriers, there's no real change, but you can see even 10 years beforehand, these are probably about the same, I guess, but 10 years beforehand, you can start to see differences. These are not people with dementia, but they look as though they probably have amyloid deposition and therefore a high risk of Alzheimer's, and then obviously at the time of diagnosis, there's obvious changes. There's some controversy about amyloid, and for many decades we've really focused possible treatment on tackling amyloid, and with the idea that if you can get rid of the amyloid in the brain, then you're not going to go on to develop dementia. But we really have had decades of no progress, and people are starting to think we've just essentially been looking in the wrong direction with this. And there are a few things that kind of suggest that. So you may have heard of the nun study, where they followed nuns for many years, and then they sort of looked at their brains post-mortem, and an awful lot of them had amyloid in their brain, but didn't actually have the clinical manifestations of dementia. So we know that it's kind of necessary for a diagnosis of Alzheimer's disease, but it's not sufficient in itself. And that might have had something to do with, I guess, favourable lifestyle choices the nuns made.
I was just about to ask, why did they choose nuns?
Yeah, for that reason, I think. So. With the assumption that they live healthy lives.
We don't know what they're all.
Men,
Yeah, that's right. Then you study monks, some might be different. So it's probably worth having a chat about this, because this is something that's kind of on the scene a little bit now. So this is this controversial drug called aducanumab. So last year in America, the FDA approved this for treatment under certain circumstances for people that have Alzheimer's disease, and it essentially clears amyloid from the brain. So you can see here, this is the different dosing strategies. This is amyloid in kind of red and orange here, and then to a degree, the higher the dose, the more amyloid you can clear from the brain. So people got incredibly excited about this, saying, "Well, this is the solution. Get rid of the amyloid, and everything's all good." The problem is that so far we don't really have the research that suggests that clearing the amyloid leads to a meaningful clinical improvement. So their cognition perhaps isn't much better. So it's been very controversial. Some members of the board of the FDA just walked out in protest because they felt it was very unethical to create this, or allow this medication to be given to the general public without real obvious clinical benefit. Other people argued, well, we have no other treatment, so, just allow us to have something. It's not without potential side effects, at least as far as we can see on brain imaging, there might be increased risk of hemorrhages and swelling and things which are relevant. So that's really, it's the only drug that we have available in the world that, in America at least, that can sort of help clear amyloid. Nothing else is around. The MABs, as they're called, there's a few others that are kind of being looked at, but that's kind of as far as we've got. The TGA in Australia, they don't subsidise it. The drug company that created aducanumab has been given, I think, 3 to 5 years to prove that the clearance of amyloid leads to meaningful cognitive benefit. Otherwise, it's going to be poor. So I imagine the TGA is just waiting for what happens.
Could I ask, with the idea that all forms of dementia are not reversible, the fact that in a 1 or 2 year time frame, the reduction of amyloid might show no change in cognitive function as in an improvement or reversal, but it might take many years before they could prove that maybe it might slow the progression.
Yeah.
Would that be?
Yeah, I think that's a reasonable thought. And then there's also a thought that if you potentially use this drug in that mild cognitive impairment, where somebody they've still got some amyloid in the brain, they don't yet have dementia, whether that's going to help it stop them progressing to dementia. So there's some hope there. But
is it too soon
Yeah, I think it is too soon to know for sure. My impression, kind of talking with colleagues and just attending sort of online conferences, is that more people are cynical about this than optimistic, but you never know. Okay, then we also have tau imaging. So this is probably more relevant once you have a diagnosis of dementia, and the pattern of tau depositions is the red sections here seems to correlate very well with symptoms. So again, very much research based, but hopefully will be helpful at some point. And then on their way, possibly clinically in this country at some point, we're going to have blood tests, which will make things a whole lot easier. So looking at the amyloid and phosphorylated tau in your bloodstream. So you have a simple blood test and it tells you the same sort of things the imaging will do. So we're not quite at the stage yet where that's been used clinically in this country, certainly being used in research and in clinical practice to a degree in America, used in research to a degree here, but I think that's a little bit of a way off. But again, it raises that issue about if you do want to know. If at the moment we don't have too much that you can do about it, and that's in itself a debate, would you want to know about it? Okay, so what causes Alzheimer's disease? After all this, we don't actually know, and we think that it's likely to be this sort of multifactorial process, and something happens to the brain, and that can be many things that then lead to the deposition of amyloid, that then precipitates the deposition of tau, that then leads to the destruction and death of neurons, and then the clinical symptoms of dementia. And the sort of things that might contribute or are the insult in the first place are myriad, and it's worth maybe spending a little bit of time on this slide just to think about it. So I've talked a fair bit about inflammation, and I've got a few slides on that. There's stuff I've read, I've got a bit more information on, so I won't go on about too much at the moment. But metabolic disease is another one. So some people talk about Alzheimer's disease being type 3 diabetes. So is it a problem with the way that we regulate blood sugar, and our ability of our brain cells to use blood sugar for energy? Does it have to do with the mitochondria? So these are the organelles in our cells which provide energy through the production of ATP. And again, some association with dysfunction, problems with your mitochondria, and all sorts of chronic diseases, including dementia and so on. So that may be something that we target treatment at some stage. Hormonal changes we've talked about, so the estrogen side of things. Vascular disease as well. So I mentioned before, if you have impaired blood supply, the chances of getting Alzheimer's disease are higher. And then there's lots of potential influencing factors. So we talked a little bit about stress and depression. There's evidence that both of those conditions can predispose you to dementia, and everyday stress now and again, relatively short periods of time, probably not an issue. We're really talking about enduring chronic, fairly severe anxiety and stress. But that does seem to be a risk factor. Other anxiety disorders like PTSD, for instance, seem to be a risk factor, and so on. Chronic depression, again, does seem to be a risk factor for dementia, and that might have something to do with that impact on the hippocampus that we've been talking about before. One of the difficulties, though, pulling that apart is sometimes with dementia, it's not the cognitive problem that is the first sign. And so you can see people in their 50s or early 60s are actually having, for the first time in their lives, significant depression or anxiety, no obvious reason for it. And then when they eventually go on to develop dementia, and you look back and you start thinking, well, was that harbinger of the process? So all sorts of things can happen at a subtle level. So we don't really know whether they're fully causal anxiety, depression, or whether it's the first signs of the dementia. Sleep, I'll talk about a little bit later on. Diet, I'll talk about the fasting and sugar intake specifically. But as a general comment about diet, it is a nightmare trying to understand what advice to give people sometimes, because it's one of those, there's this sort of diet wars basically. So everybody has an opinion on diet. I'm on LinkedIn a bit, and there's a lot of people there who are keto fanatics, and keto possibly has a place for some people, but I think sometimes people get make decisions about what's good for you diet-wise on the basis of emotion rather than evidence. What we say at the moment, being in terms of general recommendations for diet, as I say, some people would say this is not right, but the weight of the evidence would suggest the Mediterranean diet is the way to go. And also, potentially, if you have specific problems with your vascular health, this diet called the MIND diet, MIND, which is a modified Mediterranean diet. But the basic sort of ingredients of it are diversity. So you need to have a diverse range of healthy foods, and some of that comes down to looking after your microbiome. Some of it comes down to the antioxidants you get from diverse healthy foods. Green leafy vegetables, that's probably one of the less controversial things. Everybody should eat lots of green leafy vegetables. Starchy vegetables like potatoes, etc., maybe less so, but a bit of them's okay. Mediterranean diet does include things like complex carbs, so there's probably some room for them. And one of the issues actually with the keto diet, which, as you're not familiar, is more about minimising your carbs and going heavy on fats, whether it's saturated fat or otherwise, is that if you don't have complex carbs, you then don't get fibre. And if you don't have adequate fibre, then it has an adverse effect on your microbiome, your gut bugs, which then leads to chronic inflammation, which then leads on to dementia. So there is a concern about keto diet specifically for that. So fibre, green leafy vegetables, fatty fish, certainly because of the omega-3 fatty acids, and we can't produce them ourselves, and those essential fatty acids we must get through our diet. There's some again, controversy about whether vegans and vegetarians can get adequate amounts without, obviously eating fish. I think some research suggests that if you're a long-term vegetarian or vegan, you can use vegetarian sources and you process it better, so you can extract omega-3 fatty acids from things like chia seeds, flax seeds, etc., more efficiently. So the jury's out, but the general part of the Mediterranean diet does talk about fatty fish. And then, going easy on sugar. Alcohol is omitted. Actually, we never talked about alcohol. To a degree. So we don't suggest at the moment that people have to go teetotal if their brains are otherwise healthy and so on. So that's probably all I have to say about diet at the moment. Physical activity, we've talked a bit about this and the different constituents of this. Muscle mass, I'll come on to it in a bit. Microbiome health, so this is a really interesting area of research, which, so your microbiome, sorry.
I have a question, because and what about supplements? Especially that we have some, they're sort of target for the brain, like ginkgo, do you think this sort of, they actually work? Especially for vegans and vegetarians who sort of lack some nutrients?
We don't have enough evidence to say conclusively, and a lot of people take ginkgo, Brahmi, or some other supplement, and cognitively healthy people probably do get some benefit from it. There is some suggestion even people with dementia may get some benefit from ginkgo specifically. I think that may be equivalent to using some of the medications that we use in Alzheimer's. So there's definitely some evidence there, but it's not enough for us to kind of use them as a mainstream treatment. Supplements, when it comes to vitamins and minerals, there may be a role for those for some people that are obviously deficient. And again, there are different schools of thought about this. Most people would say if you can get your vitamins and minerals from food, that's far better because you have synergy between different ingredients in your food. They kind of help with absorption of each other and so on. But we have to be aware that, and I guess this is another modern dilemma, that we've got monoculture, we've got poor soil biomes. Are we getting nutritionally what we need? Who knows? And so a lot of people would say, well, if there's any doubt, you should perhaps go on a multivitamin or do those kind of things. And a lot of people do. It's an insurance policy, I suppose. Specific things that we often do recommend would be B12 and folate, so your B vitamins, and vitamin D. So they're probably good things to get tested. And even if you're normal but low normal, I'd have a low threshold for going on a supplement because they're particularly healthy for brain health. Fatty acids, so the fish oil capsules or krill oil capsules, again, jury's out on those, but if that's the only way you're going to get your fatty acids, it's probably definitely better than nothing. Krill oil seems to be better absorbed, we think, by the brain, so maybe that's preferable to fish oil. Yeah, supplements is another controversial issue. So microbiome, fascinating area of research. I think it's still in its infancy. We have lots of kind of interesting research about the impact of dysbiosis, so disrupted microbiome, on brain health. We know that, for instance, people with dementia have increased levels of dysbiosis, and you can say is that cause or effect, but we do think that there's probably some causative element to that. You know, if you disturb your microbiome, you're more likely to get inflammatory responses, which, you know, is a risk factor and so on. We even know that if you, rats at least, if you do a what we call a fecal matter transplant, which is probably obvious what that is, you give poo of one a rat to another rat, and they have the recipient will actually start adopting the characteristics of the donor. And so they've used it looking at cognitive aging. So they'll give a young mouse the fecal matter of an old mouse, and then they'll test the young mouse, you know, very soon afterwards, and then they'll see that it's actually got the cognitive function of the older mouse. So, you know, it's an interesting area of research. I'm not suggesting it's a solution, but, you know, it's kind of definitely something that's got a lot of people's attention. UQ, there's an organisation called Microba where you can actually get your microbiome tested, about $350. A lot of interesting data. It's, you know, what do you do with it? I'm not sure. Probiotics are very good, fermented foods and stuff you might find. Obesity we'll talk about if we have time. How are we going for time anyway?
I think we're going okay. Yeah.
3:30.
Alcohol, yeah. So we know that alcohol can cause alcohol-related dementia. We know it can cause vascular problems. We know it can cause Alzheimer's disease. But the jury's really out about how much is a problem, whether a little bit is better than none. I just don't think we really have the evidence. Theoretically, things like red wine have useful antioxidant effects in the blood, can be quite beneficial for vascular health. But that notion has been challenged to a degree. As I say, my advice to people is, you know, as long as you're relatively healthy, don't completely stop alcohol, but keep it in the guidelines, which is in Australia now 10 standard units a week, less than 4 in one sitting, which is, you know, a bottle of wine a bit in a week. It's tough sometimes. Loneliness and social isolation we've talked about, hearing we've talked about, and complex mental activity I think we've touched on as well. So this is, again, not exhaustive, but I think it's a kind of list of different things.
Just a quick question, is ethnicity a factor too?
Is what?
Ethnicity. What
Ethnicity.
group you belong to?
Yeah.
You're Asian or indigenous?
Definitely. Yeah, definitely. And I can't talk about sort of in any detail, but we certainly know that certain ethnicities are more likely to get problems with their brain as they get older. Certainly, if you are of an ethnicity where your vascular health, where your blood supply is more likely to be compromised than the Pacific Islanders, for instance, you're more likely to develop dementia later on as well. So some ethnicities seem to have favourable profiles and some less so. But yeah, that's definitely...
so which one on the list? Where you thought that I could change?
Well, I think, you know, again, so from India, from Japan, is it a cultural thing? Is it a genetic thing? I'm not quite sure, but they're two areas that have favourable profiles. African Americans, a lot of South Americans, Puerto Ricans probably have a less favourable profile and things like that. So, yeah, it's a big area. I probably can't talk much more about that.
I heard there's some correlation to mountainous peoples in places like Pakistan, but I don't. It's just something I heard. But mountainous people.
Oh, mountains.
Right. Mountainous area here or something. I have no idea.
Well, you know, that could be due to a number of things. And when you look at longevity in general, and you know, there's an obvious connection between lasting a long time and being healthy and therefore reducing the risk of dementia. Certainly a lot of the zones, like, you know, Sardinia, I think it is, the people that have particularly favourable profiles are the mountain there, you know. And is it that they're kind of going up and down the hills all the time? Is it the fresh air? Is it, you know, the the sense of kind of community they have. There's all sorts of metrics, but yeah, that doesn't surprise me.
Can I just, maybe we're going to cover this later, but I wanted to ask, if you ameliorate sleep problems by, say, benzodiazepines or melatonin, is that sufficient to influence the effect of sleep on dementia? Or is using those things a problem in themselves?
I might come.
You're going to, okay, thanks.
What about being bilingual?
Yeah, so that's protective. Yeah. Yeah, and yeah, so bilingual, polylingual certainly is protective against dementia. Yeah, and maybe that just comes to that complex mental activity side of things. You're just using your brain more, but that's certainly a protective factor.
About the mountainous people, someone asked a question. My thinking on that one is because their life is so simple. I think they are way away from any stress. I have gone there, I have seen that. They are still living in perhaps 4 or 5 centuries behind us. So I would say absolutely no stress, very pure food, and yes, and as you said, community, very strong community supports.
It's a big thing.
Maybe these 3 things I have seen there. And, very pure, very clean environment and food.
Yeah. So if I was to sort of transplant my current life and live in the mountains, do everything else the same, maybe I wouldn't get much benefit. And maybe it's that other stuff that comes along with kind of living in those environments is quite right.
Even in nowadays, there are no Wi-Fi's, there are no televisions, absolutely nothing. They just get together and talk.
Yeah. And certainly, when we were talking before about loneliness, social isolation, you'd have to imagine the rates are considerably lower in those environments, less inflammation, less stress.
I'm still waiting for when we talk about the sleep.
Okay, we'll come on to it.
Sleep is my problem.
Yeah, mine too. It's a shame. One of my problems. Anyway, inflammation. So just a brief word about how this all might work with Alzheimer's disease. So acute inflammation, of course, is necessary. We talked about having the ApoE4, having a better inflammatory response, surviving infections and things more easily. So we of course need that. The issue when it comes to inflammation is when it's this kind of chronic, ongoing issue. So we talk about these things called cytokines, which are these inflammatory molecules. And a lot of what we do that seems to lifestyle factors that kind of induce chronic inflammation are a result of what we call, I remember somebody calling cytokine drizzle. So this kind of continuous release of inflammatory molecules into our system. And so this is the brain, this is the impact of a infection, which causes one of the causes of inflammation. It can either be infection or sterile. I'll come on to the sterile in a minute. This is some sort of bug that's kind of entered your brain, your microglia, which is one of those cells that I talked about earlier on, releases these cytokines. It creates this immune response that then cuts this amyloid precursor thing. So this is a sort of neuron wall, if you like, and it cuts it in such a way that it creates the beta amyloid, which is the thing that we see in Alzheimer's. And then the beta amyloid, under circumstances that aren't necessarily related to dementia, then seems to trap the microbe. So this is kind of beta amyloid is effectively a double-edged sword. So if you have too much of it, it's a problem, your nerve cells die, etc., but you possibly need some of it. And we can actually see from studies that if you, for instance, infect mice with certain bacteria or microbes, then those microbes are then colonize the brain more readily, and we can actually see these amyloid plaques surrounding these microbes. So it actually has an antimicrobial effect. So if we had no beta amyloid, we'd be in trouble, but the issue is that we've got too much of it. And that study with the mice is quite interesting. So that was actually, they infected them by basically putting this bug called Porphyromonas gingivalis in their mouth, which is the bug that creates gum disease. So we all have some of it. And so there's a real concern about oral health, which I'll come on to in a minute, and how that actually might be impacting our risk of dementia later on. And we know, for instance, that if you've had 5 teeth out by the age of 65, your rates of dementia go up significantly, and so on. So infection can definitely be a problem. Amyloid might be the bad guy, but only if there's too much of it. So other infections that might have been linked with Alzheimer's would be herpes and Lyme disease. Both of them seem to result in that. There's been some evidence to suggest that. So this is a chap from the Battle of Visby, which was in the 14th century. Doesn't look in very good shape. But his teeth are not bad. And so when we examine the teeth of people in the Middle Ages, only 20% of them actually showed signs of decay. Nowadays, it's 50%. It's actually better than it was kind of 100 years ago, when it was about 90% of people. But the decline in oral health in general compared to the Middle Ages might be one of these kind of factors, and it might be linked, as I say, to the infections that cause gum disease, and then the inflammatory response of the amyloid in the brain. And the main reason we think we have more decay now is not because we're looking after our teeth less well, we're flossing, brushing more than we ever have, but because of our consumptions of sugars and also potentially grain, which gets converted into sugars with time. So this might be one of the reasons. I mean, it's very hard to make judgments because a lot of people obviously didn't live to an age back then where they would have developed dementia anyway. But this is, I guess, an increasing area of research. And the sugars and the grains also essentially promote the wrong kind of bacteria, and that's the issue. All right, so I'm going to spend a little bit of time just talking about sugar. Get a little bit obsessed about this. Not that I have very good control of my own sugar intake, but I am aware it's a big problem, and it's not just due to dental issues. We talked about the role of insulin, and I'll come on to that in a minute before, but too much sugar over a long period of time causes this thing called insulin resistance. It can also cause metabolic disease, so that's problems with blood pressure, cholesterol, weight, etc., and causes chronic inflammation directly. So there's a lot of reasons that having too much sugar is really bad for your brain. And this was just a thing that I catched off the internet, talking about sugar consumption from 1822 to 2012 and how much it's increased by. And I've actually seen stats that show even more alarmingly than this, that the actual amount we eat in a week is 150% more than we ate in a year back then. So the stats vary, but the point is that we are over-consuming sugar, and it's everywhere, and you kind of clearly see that. Having diabetes, which is kind of the end point of sugar control problems, doubles your risk of developing dementia. And we also have research, and again, people don't really appreciate this, that when we test your blood sugar, you have a normal range, of course. If you exist in the normal range, you're still there, so you've got normal blood sugar, but you're at the higher end of it. That's still associated with cognitive decline. So, the blood sugar normal values were perhaps initially created for looking at other processes and how much risk they were. It's only more recently that we're kind of looking at the impact on the brain with that. So whenever I see somebody who's got normal blood sugar but it's high, I still say, well, that's something we need to address.
Sorry, under diabetes, is that only type 2 diabetes that will double your risk, or type 1 will?
Both. Yeah. And I'll come on to the reasons why that might be just in relation to insulin in a minute. But yeah. Okay, so sugar. So here's your brain on sugar. Here's your brain on crack cocaine. And so you can kind of see that sugar is, at least according to this, more of a problem in terms of the reward pathways, the motivation pathways, etc., than illicit drugs and things. And I guess it's just an important point to make that a lot of us struggle with eating too much sugar, and it's not surprising when you see kind of what it does in our brain, that it's hard to cut it out. Why does this happen? From an evolutionary point of view, it makes sense that we go for things that are immediate sources of energy, because we really are just focused on the here and now survival. The problem, of course, is that now we have ubiquitous sugar. Back then, it was scarce, so you had it when you can. nowadays it's everywhere, so it's very hard. But the neural architecture and the physiology of the sugar consumption and the responses that show why it's so hard to kind of keep the habit. There's also this really interesting connection with uric acid. So uric acid is involved in converting fructose, a type of sugar, into fat. And we know that the fat is a problem for dementia. We know the weight is a problem with dementia later on. And there's this story that in the Ice Age, last Ice Age, there were some individuals who ended up basically being like ancestors that had a genetic mutation of their uric acid that meant that they went from not being able to convert fructose sugar into fat into being able to do that. So the Ice Age came about, there was less food available. Those who could convert sugar into fat were more likely to survive because there was a scarcity of food. Fat provided an alternative source of energy for them, so they're more likely to survive. So again, we've kind of got this inbuilt propensity to accumulate fat, which is a problem for our brain, simply because of its genetic variation that was actually helpful at the time.
Excuse me.
Yes.
Or is there a connection between sugar and not using the brain too much? Because generally speaking, in layman terms, sugar is the fuel for brain. So if someone is not using the brain at all, does sugar is needed for brain? Is it?
Yeah. So sugar.
I mean, accumulation of sugar there. Is it due to lack of activity of the brain or something, or?
Well, glucose or sugar, type of sugar is the preferred fuel for the brain. So it will always use glucose, sugar, if it can. Whether it needs it all the time is questionable. And I guess this is one of the things, and I do talk a little bit later on about fasting and using ketones, which are other energy sources, an alternative to glucose. So the brain will always use glucose if it's available, and it's a very effective kind of source of fuel for it. Okay, so 80% of American food items have added sugar. It's very hard to avoid. So just talking about insulin a little bit. So insulin is a hormone that helps push glucose or blood sugar into the cell to provide energy, and high levels of blood glucose or sugar lead to high levels of insulin, which means that cells become less responsive to insulin, which means the blood glucose stays high rather than being transferred to the cells, and round it goes. So it causes this problem of insulin resistance. So you lose sensitivity, become resistant. And so that means that glucose isn't transferred to the cell, and then it gets converted into other things. So in this case, fat. It's also, glucose or blood sugar is also stored in your liver and skeletal muscle. And we talked about muscle mass and resistance exercise, weight exercise earlier. So it's just an interesting kind of hypothesis that if you have high levels of skeletal muscle, and particularly if you're exercising soon after or around about the time that you're using glucose, it may well be that pulls a lot of your blood sugar into your muscles, whereas far less of a problem circulating as a kind of high blood sugar situation. So maybe having higher muscle mass of exercising and using your muscles is actually a way of kind of reducing this. Following on from your point about use of glucose and those sort of things in the brain, so those people who have Alzheimer's disease have been shown to be more insulin resistant, which means they're less able to use glucose as their energy source, which is why it's called type 3 diabetes. So this is a problem, and there is evidence to suggest that some people with Alzheimer's disease do actually do quite well on ketogenic diets. They're getting their energy source from ketones rather than glucose. So it's sort of, I guess, more research is needed, but it's an interesting sort of point. Insulin also has other roles. It helps with neuronal connections. It might itself clear amyloid, and it helps with vascular health as well. So it's got a lot of different roles. These days, we have quite a few tools that we can help to monitor blood glucose. So blood glucose strips have been around since 1965 and generally used by diabetics. For the last 15 years, we have these things called CGMs, or continuous glucose monitors. Anybody ever used one of these things? Don't have to be diabetic, but yeah. So
yeah, just interest.
Yeah, so I've done the same. So over a period of a couple of weeks, which is how long they last, around about then, I just tracked my blood glucose, and it gives you a sort of trailing picture of what the blood sugar is doing after you eat certain things or do certain things. And it can be quite interesting because different people seem to have different responses to different foods. So you give two people exactly the same thing and their blood sugars will vary. So really to get a kind of tailored idea about how much of a problem blood glucose is for you personally, something like this would really be quite helpful. And then you could use this for a while, and then you could use certain things that might help. Metformin people use sometimes, supplement called berberine sometimes used, and that controls blood sugar. So it gives you a really good idea about what your blood sugar is doing. And you'd be quite surprised at what spikes it. I remember having a generous almond croissant in a German bakery, hardly spiked at all. Oh. And then I had a pot of yogurt and it went sky high. So, go figure. So I think there is some controversy about these things, but I think they can be very helpful in giving you an idea about your own blood sugar responses.
Is there an Apple app for that?
You have to get that device. So this thing sits on your normally up there. It's got a little needle in there, and you just put it on, and it just kind of monitors your interstitial glucose. But then, yes, there is an app on your phone that goes with it. But it's a device. Then we have the Glycemic Index, which you're probably all quite familiar with. So we can get an idea what sort of effect certain foods and things are actually going to have on the blood glucose at any stage. And this is just a guide. As I say, people do vary, but it's good to know what's likely in general to spike your glucose, because if your blood sugar is spiking all the time, that's not good for your brain. Having low GI is better than high GI. Fruits, for instance, you're far better off kind of having berries rather than mangoes and so on. How it's cooked affects it, what it's eaten with affects it. There's all sorts of things. So it's another useful tool, but not the be-all and end-all. Metabolic disease, I might go through this fairly quickly because I'm conscious of the time, but this is basically metabolic disease is probably the cause of the vast majority of chronic diseases, including things like dementia and Alzheimer's, but also vascular disease and so on. So there's a kind of a thing called a metabolic syndrome, which is a cluster of 3 out of these 5 things. So having central obesity, having high levels of triglycerides in your blood, which are bad fats, if you like, reduced HDL, which is a good cholesterol, having high blood pressure and high blood glucose here. And almost 90% of people have at least one of these metabolic dysfunction parameters. And so it's a real issue. And we think that having full-blown syndromes at 3 or 5 increases your dementia risk by up to 10-fold. So having vigorous control of these things, I think, is really important. Obesity rates going up, no surprise. So 1975 to 2016 here, you can see how much they've gone up from 10% there up to 30%. And then you can see here, I think this is, I'm not sure whether this is Australia or America, but we're not that dissimilar when it comes to these issues. You can see a very high proportion, I mean that's 38 and 37%, so that's 75%, 3/4 of people when they reach a certain age are either overweight or obese, so it's a big problem. Why is it happening? We don't really know. Certainly there probably are dietary factors, and coming on to that discussion initially about the modern brain and the modern environment. We have things in our food environment that are clearly not good when it comes to being managing weight. So high fat stuff, high sugar, high salt are all going to be problematic. There are some people that are just genetically predisposed. Sedentary lifestyle. So this is again interesting. I couldn't find too much data on this, but this is a slightly overly complicated graph, I think. But it basically shows these things that the MET is a metabolic equivalence. It's kind of a sign of how much activity you're getting. And if you look back in 1960, I think that's the wrong way around, sorry. So this one here, that's the average amount of hours per week being sedentary. So if you go back to this black line, it's that one. So we are are considerably more sedentary than we were back in the 1960s. And then if you look at the breakdown of where we are active, so PA stands for physical activity, the thing that really has changed most obviously from 1960 to 2030 is how much physical activity we're getting through our jobs, our occupational physical activity. So it's really gone down. We have slightly increased in this, which is our deliberate kind of exercise, if you like. But so we are expending less energy and spending more time being sedentary, and it's a clear connection. Might be other things. Microbiome disturbance, pollution, toxins can all have an effect. Medication. So it's a complicated field. Obesity. So not all fat is created equal. So really, when it comes to brain health and chronic disease in general, the issue is central obesity, or what we call visceral fat, that's the fat around your organs. And we know that the more visceral fat you have, the thinner your cortex, which is one of the signs of neurodegeneration and shrinkage of other brain structures. You know, it can have a problematic effect on your blood supply, and it can also increase sterile inflammation, which is not good for your brain. We can measure this using BMI, body mass index, but that's of limited value because you can have people who are just muscular, who have a high BMI. So if you're just doing a simple clinical test, probably the best thing to do is your waist to hip ratio, where you measure around the level of your belly button, the highest parts of your hips, and then you'll get a calculation, and you, depending on how much of it is, you can tell whether it's excessive or not. So that's a good test of abdominal obesity, which is a proxy of visceral fat. And this is just a graphic to show how inflammation is increased. These are fat cells here. There's a reduction in anti-inflammatory factors, but lots of these things like interleukins go up. So visceral fat is really the issue. If you're really interested, and I try and get my patients to do this, I get them to do body composition scans. So you don't need a referral for this. You can just go to one of the private radiology firms. And these body composition scans or DEXA scans show you what you're made of, effectively. So it will actually show you the distribution of fat within your system. So all this stuff here is really not too problematic. There's much more kind of subcutaneous. But when you start getting kind of strangling things within the abdomen, that's more of a problem. These scans will give you a figure of how much visceral fat you have, which can be very helpful if you're trying to sustain long-term behaviours, because if you know you've got a certain amount of visceral fat now, and you put some intervention in place, you re-measure yourself using another DEXA scan and you've improved, is kind of a motivating thing. So I think having numbers, measurability is really helpful. The other thing about this is that sometimes you can be what we call photy, fat on the inside, so you can look quite skinny, or skinny fat, but actually when you look at the scans, you can have visceral fat. So it's a better metric, really. These are often used for bone density, because incidentally, and also muscle mass. We talked a bit about muscle mass before, but it seems that the more muscle you have, the better your brain's going to be for it, to a certain extent. Your seeding effect, so high hippocampal volumes, increased activity on brain scans. And this is probably mediated by this brain-derived neurotrophic factor, that neural molecule we talked about before, which we know is good for synapses and growing neurons and so on. And so really, when we talk about the importance of different types of exercise, I would always suggest somebody does at least 2 sessions of resistance exercise per week, along with all the aerobic stuff, because that seems to be helpful. Lots of other ways to increase BDNF. These are similar to the ones that affect the hippocampus. So there's an obvious link there. Exercise, antidepressants we talked about, antioxidants. So again, best coming from your food, but can come in the form of supplements. There's resveratrol, you've probably heard of. It's what's in red wine, although you have to drink gallons of red wine to get the benefit. So there's an argument to be made about using that as a supplement form. Curcumin. We talked about India having lower rates of dementia, and perhaps people have postulated maybe it's to do with this turmeric and the impact that has on oxidative stress and inflammation, and then the omega-3 fatty acids, intermittent fasting. I might skip through fasting. I've got a few slides on it, but it's in the interest of time. But that's quite an interesting topic, really about benefits, not just of increasing BDNF, but on blood sugar as well. Adequate sleep will come to that. Socialising, avoiding processed foods, reducing stress. Sensible kind of stuff.
So I think I missed that. Curcumin, is that curry? Or?
Yeah, turmeric. So current.
Turmeric. Right.
Yeah. So that's what I'm saying. Right? It's thought that maybe perhaps one of the reasons Indians have lower rates is because of some dietary effects.
Because turmeric is also anti-inflammatory. Does it
and
connect there somewhere?
That's thought to be the connection, really. So antioxidant is really the same as anti-inflammatory. The problem with this, I mean, I think there is, out of all the different supplements for your brain, this probably has the best evidence, but we haven't quite got the formulation right to get it in a capsule form that's available to the brain. There's something called ferrocumin, which is a type of curcumin, which is probably better, but we're still working on it. Okay, I might just skip through this. Anybody do intermittent fasting? Okay. I might just cover it quickly then, because I think it's a very popular topic. Okay, so also known as time-restricted eating or feeding. There's some argument that it's the way we're supposed to live, going through periods of feast and famine. And there's some suggestion that actually our cognitive skills have become as good as they have because of the need to acquire food and so on. And the basic idea with fasting is a kind of as a driver of energy production and switching is that when you fast for long enough, you lose access to that glucose and you start to use ketones, which may be the fat you have. And so when you have scarcity of food, that's more of a kind of chronic source of energy that you can get. So what even is fasting? I think it's a fuzzy definition. I think the basic idea is that you need to use up all your stored glucose, your glycogen, and start to use ketones as an alternative energy source. You can check this by peeing on a stick, pricking your finger, etc. Breath often smells sweet. It's thought to be around about 16-hour mark that most people get there. If you exercise a lot or have low-carb diets, you probably get more quickly. And this has a number of benefits. I don't think anybody would really argue that your average person wouldn't get some benefits from intermittent fasting. Reduce inflammation. Autophagy is kind of the process of cleaning up dead cells. Improves insulin sensitivity, blood sugars. Increases human growth hormone, which reduces fat, increases muscle, which is good for your brain. Ketones, as I say, neurodegenerative diseases are maybe helpful. And then seems to improve microbial diversity as well, so the microbiome health is improved. Cognitive benefits, upregulates BDNF. Ketones are not reliant on the insulin function, so we've talked about that. We don't really know whether intermittent fasting itself helps acutely. I've read studies that say different things. You think it would make sense from an evolutionary point of view that being hungry should make you sharper because you need to access food somewhere, so you need to be more switched on to find it. But I think the study showed mixed evidence. Certainly, personally, when I've fasted for beyond 16, 17 hours, I just feel terrible. So I think people have had very different experiences. I'm not saying I've had any cognitive enhancement, quite the opposite, but everybody's different. So in terms of neurodegeneration and dementia with intermittent fasting, so we know that intermittent fasting can slow down amyloid production and cognitive decline in animals. We know that time-restricted feeding for a month or so can really reduce amyloid precursor protein, so that's the thing that sits in the membrane wall that then gets converted to beta amyloid. A blood test. We know that regular periodic fasting, so that's not fasting for a whole 24 hours, twice a week, improved cognition in those with mild cognitive impairment. And we also know that, and this is kind of a proxy, if you give somebody ketones after fasting, it improves their cognition as well, even if you have Alzheimer's disease. So there certainly seems to be signals of benefit. Okay, and then finally, sleep. For anybody that really is interested in sleep, this is a great book. Yeah,
I've been waiting.
You're waiting? Yeah, okay. Just a few slides. I obviously have to cover this in fairly brief detail, but that's a great book. And if you ever heard Matthew Walker speak, it's very eloquent chapter to listen to, so it's really worthwhile reading. Are we getting less sleep? We don't know. The assumption is that we are, but actually I don't think the studies really bear that out. What is happening, though, is that we're getting more neurotic about our lack of sleep. And it's coupled with the fact that we now have access to some of the medications you were mentioning. So sales of melatonin gone through the roof. We also have sales of other hypnotics. So this is Zolpidem, which is a Z drug, which is similar to things like temazepam, similar mechanism of action. And this is data from a little while ago, but you can see that there is increased use that then results in harm. That means that people present to emergency departments. So the amount of people that are on these kind of medications, whether it's melatonin or other things, has gone up significantly. Some of it's marketing, no doubt, but it's a concern. Personally, I'm far less worried about melatonin. I think there's a few people out there that are worried about using melatonin on the long term. But certainly, if you're going to use anything, I would much prefer to use melatonin than one of these other drugs over the long term. Coming to your question about whether these medications increase the risk of dementia rather than improving sleep and helping, certainly there's evidence that these things, so Z drugs and benzos, may increase your risk of dementia. It's a little bit hard to know because, again, the kind of person that might be on these things periodically, might be more anxious and stressed in the first place. Yeah. And so is it the anxiety and stress that's the risk factor for dementia? Or is it the drug? So we don't really know. But we do have evidence to suggest that using them in the long term, there can be a problem, just specifically that kind of medication. So 20% of Americans took a natural remedy to get to sleep in the last year. And in one study, almost 1 in 10 Americans said they'd use a sleeping tablet to get to sleep 4 times in the past week. So that's quite a lot. And so one study showed that there was more than a doubling of risk of dementia in those taking long-term benzodiazepines or Z drugs. But is it a confound or is it true? We're not really sure. Who is struggling to sleep? This is self-reported data from England. Perhaps unsurprisingly, it's people who have to hold down jobs and look after kids reporting poor sleep. Women consistently report less sleep or less happiness with their sleep than men. And the other thing I thought was quite interesting is that the older you are, the less likely you are to complain of sleep. So this isn't objective sleep deprivation, it's your thoughts about sleep. And what we know is actually you do get less quality and less quantity sleep the older you get. So they're just complaining less. But certainly, quite high prevalences of these things. Sleep across the ages. So this is when you're born. You have an awful lot. You're sleeping up to 15 hours a day when you're born. And I suppose probably the more useful comparison would be early adulthood to older age. And you can see there's a diminishment both in your non-REM sleep and in your REM sleep. And both of these things I think can have some impact on the brain. We can do these things called hypnograms where we look at the brain waves at different parts of sleep, and we can see whether people are in deep sleep or in lighter sleep or REM sleep and so on. And you can see again the architecture, the sleep architecture is quite different in a young adult where you're getting a lot of this deeper sleep compared to an elderly person. The elderly person is kind of waking up a lot more, they're getting a lot lighter sleep. And we are wondering whether this in itself might be one of the causes of the high risk of dementia as you get older, the poor sleep issue. The other thing to mention here is you tend to get deep sleep early in the night rather than later in the night as well. Why sleep matters? Well, it really matters for everything. I'm not really going to go on too much about this because it's more the cognitive side of things, but we know it's increased risk for all sorts of issues. This is just some data on looking at hippocampal activity. So we think that the stage between deep sleep and non-REM sleep, the stage 2 sleep, seems to be particularly helpful for memory consolidation. And when you compare those who are sleep deprived versus those who sleep well, there's a significant change in the hippocampal activity here. So we know that during this time, the hippocampus activity increases. This is a similar graph, although this was actually done on students who were either sleep deprived, the red one, or not sleep deprived, and then given a sort of cognitive test. And you can see the coding of various things or the performance of the task was significantly better if they were not sleep deprived. And again, it seems to be correlated with hippocampal activity. Then there's this issue of deep sleep, and I find this a particularly interesting element. This is the last bit of the presentation, just later. So when we're in those deeper stages of sleep, we believe that we effectively go through this brainwashing process. So I think in about 2012, 2013, there was this system identified called the glymphatic system, which is this kind of system of channels that lie alongside the arteries and the veins in the brain. And what they effectively do is when you're in the deeper stages of sleep, it seems as though, possibly in part because your arteries are pulsing as they do, and it's then pushing the fluid out into the brain tissue, and it's a sort of gradient effect, and then it washes out a lot of molecules that otherwise would be problematic for the brain. So pro-inflammatory molecules, amyloid, tau, etc., and then it washes them into, I guess, the venous system on the other side, in effect, or into certain nodes. So when you're sleeping deeply, you get this brainwashing effect. You clear the brain of amyloid and tau and all these other things. You can see that sort of passage as it's happening there. So if you don't sleep deeply, you're not getting this effect. The brain is potentially then more inflamed, carrying more amyloid and tau, and maybe then you're putting yourself at greater risk of neurodegenerative disease. And certainly there is a link between poor sleep and dementia risk later down the track as well. Again, it's not if you have intermittent sleeping problems, it's a protracted kind of issue. So the glymphatic system probably declines with age, which again might explain why, as you get older, dementia is more likely to occur because you can't clear all these molecules. And some of that has to do with the fact that as you get older, your blood vessel walls are stiffer, so you don't get that pulsatile effect, so you don't get the fluid pushed out quite as readily, and there's less fluid production, and your heart's less effective. So it seems to rely on the vascular system. Yeah, so that's essentially the glymphatic system. It's a very kind of elegant system, I think, the glymphatic system, and it kind of explains a lot of different things potentially. It's a hypothetical idea, but we do have some imaging to suggest that the glymphatic system does exist, and we've shown how it might be affected by various things. Lying on your right side might help, simply from a mechanical point of view. There's some suggestion in animals that if they're lying on their right, on their left, or on their back, then they might have better glymphatic clearance. There's an idea, controversially, that alcohol might improve glymphatic clearance. Again, I think that's an animal study where they just gave a little bit of alcohol, compared it. So those things possibly help too. But I'm not telling you to drink a lot. And then there's also interesting data about dietary factors here as well. So we know that if you take those omega-3 fatty acids, again, that can help the health of the glymphatic system through various mechanisms. And we know that even if you just sleep deprived for a single night, you have high levels of amyloid and tau, those populating proteins in your brain. So it's something to be aware of. It's always a bit of a potentially alarming thing to hear, isn't it? Particularly if, like me, you're a bit of a chronic insomniac, to be told that you must sleep better or you're going to get dementia. Not quite like that, but I think you just need to be alarmed, do what you can about it. So measuring sleep, if you can, measuring quality and quantity is helpful. Some people just say, well, you just measure it on how you feel, each time of the day, etc. That's enough. Some people use the spoon test, which you may have heard of, where you basically, during the day, you lie on your bed, you have a spoon in your hands over the side of the bed, you have a metal spoon, metal tray underneath, you put a timer on, and you try to fall asleep in a darkened room, and at some point you will fall asleep, the spoon will drop, hit the tray, wake you up, and then you work out how long it took you to fall asleep. And there's a rough metric that if you fall asleep within 5 minutes during the day, the spoon hits the tray within 5 minutes, then that's a sign you're sleep deprived. It takes more than 15 minutes to really do a problem. So it's just another way of looking at it. And then polysomnography is really the gold standard, but none of us do that every day. So it's helpful, useful for things like sleep apnea as well. It gives us very interesting data like those hypnograms are showing you. And then this is an Oura ring, so this is a sleep tracking device. Anybody got an Oura ring? Yeah, I've got one on hand. I like it. It has pros and cons, I think. But you get data which is helpful in some ways and unhelpful not. So this is my era data without disclosing too much. So this was a reasonable night's sleep. I'm always restless. I have no idea why. But, I've got a decent amount of REM sleep, deep sleep. And this is a bad night where, I should pay attention, that sort of thing. So you can kind of get a rough idea. But the problem is the correlation between this and the polysomnography. And we don't. So there's some correlation. I think that 80% of the time, these kind of trackers can tell you whether you recognise properly when you're asleep versus being awake. I think the data suggests that maybe only about 40% of the time it can accurately detect what stage of sleep you're in. So there's lots of different kind of limitations to this data. But I think what is helpful is if you start off with this, and then you put some intervention in place, whether it's melatonin, stress reduction, depression, not drinking so much alcohol, and then you consistently get that pattern, then I think you can take that as a good sign. So again, it's a way of measuring it. And this was me in February. I opened my clinic in January. It was a nightmare. Everything was going wrong. I was quite stressed. And so this kind of sleep score was really quite poor. And since then, I've improved significantly. So that's quite good. That to me is quite comforting. The issue becomes that you can become obsessed about this stuff again, of course. And I'm glad that from a personal perspective, mine's trending up rather than trending down, because you can over-interpret this data and worry you and so on. So you kind of need to be able to use it at the right level, I suppose. Okay, and then just very briefly, what you can do about sleep, an awful lot of information, sometimes a very brief thing, but sleep hygiene, you've probably all heard of sleep hygiene, I suspect. There's lots of measures about different environmental, physical, behavioural things that you can do. Just Google that term. Cognitive behavioural therapy for insomnia is more about looking at your behaviours and your cognitive analysis of your sleep. And that's actually been shown to be helpful in up to about 75% of people who have chronic sleep problems. So that's actually really quite effective. Then you can use things like melatonin and valerian, which are relatively benign. And then the hypnotics, the benzos, the Z drugs and things. I think in the short term, in a stressful circumstance, etc., it's not really too much of an issue, but it's the long term you have to be aware of. Okay, we're at the end of it. So optimising brain health should be multifaceted and lifelong if you can. Modernity is a double-edged sword. I think we've certainly got some really useful ways of measuring things which can help our management and treatment and approach to things. But of course, we've outsourced a lot of our cognitive function, our dietary changes have caused us problems, and so on. So there's a lot of kind of problematic things to do with the world. But I think we need to do a lot more. I've just given you a bit of an overview of some of it. So I hope that's helpful.
I hope everyone found it a really fascinating talk. I mean, not just in terms of the content, it's really interesting material, but Dr. Kailas has given us some really useful practical tips, how to maintain our brain health, through our life. And since socializing is good, wine is not ruled out, so we are going to do a bit of socializing at Jimmy's on the Mall. And just keep your drinking, within limits so that you don't offset all the benefit that you have got from this lecture today. So see you at Jimmy's on the Mall. Thank you.